It's a couple of slides so that you can follow along, right? That document how to install the various libraries that you need and what you need to configure in your projects. Okay? The assignment walks through this as well, right? And so it's a good idea to just keep both of them open just to verify that you're doing it in the correct order. Right? So one of the first things that we'll need to do is to install a couple of libraries that are going to allow MongoJS, right, to maintain some session information about us. Okay, what we're going to do is that we're going to have Passport challenge us, right? Every time, any time that Passport doesn't know who we are. Okay, so there'll be some sections of our application that will be public. Okay, that we shouldn't be challenged for logging in. Okay, I believe that's actually one of the requirements in the assignment, right? In the project, rather, that there should be a section of your project that should be publicly available to everybody, right? That you shouldn't be challenged to log in to look at the public section. But if there are private parts of the application, we should be challenged. For instance, if we try to navigate to somebody's profile or my own profile, or if I need to store something in the database needs to know, the application needs to know who I am. So certainly it needs to challenge us to know who we are. Yes? So we would like Passport to be able to remember, right, that we have authenticated. We'd like to remember that it has already challenged us, and we have already provided our credentials. Okay, and the reason is that every time that any event, as I submit something, or every time I go back to the server or post or get something, right? Each one of those is a individual interaction between the browser and the server, right? And some of that communication is going to be public, right? As I peruse and browse through the public part of the application, a lot of that communication will be public and won't need to be challenged. But once I go into some private location, maybe I go into my profile, yes, and I am looking at all my private information and all my profile information, I would like that communication between the browser and the server to be secure. Correct? And so as far as HTTP is concerned, as far as the server is concerned, each individual communication, each individual get, post, put, delete, they're all individual, right? There is no notion of remembering anything between one get and the next post or the next put. As far as HTTP is concerned, there is no state. Right? There is no remembering that it's still me. I just logged in. Okay, I'm gonna send you another get. I'm navigating to another page. It's still me. There's no notion as far as the server is concerned that it's still you. Yes? Up to this point, we have been maintaining state, not on the server. We have been maintaining it in the URL. Okay, by encoding the ID of the user as part of the URL. And every time these URLs go back to the server doesn't know it's still us. Right? We have encoded the logic to use the user ID to reconstruct the state from this user ID. Yes? So that once we have the user ID and we have the website ID and the page ID, we can then query the database within that context. Yes? And then provide the data for that particular context and then give it back to the client. Once the browser server sends that data back to the client, it goes back to not remembering anything about us. Right? If we go and refresh the page and ask for exactly the same information, the server will again reconstruct the state from the user ID and the website ID and the page ID and again ask the database for the same information and send it back to us. There is no notion of remembering that it's still me. I just asked you the same thing 2 minutes ago. Make sense? Right? So we've essentially built, on the server side, we've built what it's referred to as a stateless application. A stateless server application. Yes? And it's a good thing because we're not asking the server to remember anything about us. Okay? And stateless applications are easier to scale. Right? We're putting little demand on the server to remember anything about any particular person. Imagine that it had to remember who I am or information about our last query. Anything that I asked it to remember, it needs some RAM, right? Instantiated for me, and then for you, and then for somebody else. It would need to maintain some RAM instantiated to remember information about all of us. And perhaps it's okay for 5 users, 10 users, 100 users. But imagine when you're talking about that this is an application that is in production and it's thousands of users, right, querying the server, and it has to maintain information about thousands, hundreds of thousands of users. It would not scale. Right? We're asking it to use that we would need more RAM, more CPU, right? All of the footprint of your server just grows linearly, right? For what information you're asking for. Make sense? But if it doesn't have to remember anything, the only limit is, well, how fast is your CPU to go out to the database, reconstruct the state, and then send it back. Okay? Those cycles are they're lightning fast compared to whatever network traffic latency there might be. Right? So reconstructing this for the CPU to reconstruct the state compared to the latency that the internet provides, it's just lightning fast, right? It's nothing. Right? It's very fast. Okay. Right, but there is certain things that we would like to be able to remember. There's a couple of things that we do want to remember, such as things that we don't want the client to know, or things that we don't want to send back to the client because there might be some security concern. Right? For instance, we would not want to have the user ID, for instance, just spread all over on the client side. Or if it is in the client side, at least we would like it to be encrypted, right? So that it would only if the ID is ever shared back and forth between the client and the server, it would be encrypted, and then when it goes back to the server, it would be unencrypted, and then we can reconstruct the state again. That makes sense? Right? So that's one thing. The other thing is that since we're going to be using authentication, and we want to protect all the queries that go back and forth, right? We don't want to have to be challenged every single time we navigate through the protected area of our application. Remember, HTTP just doesn't remember, right? The server doesn't remember normally, right? How would it know that we authenticated? We just logged in. There would be no way for it to remember that, hey, we just logged in the previous page. Don't ask us to log in again. It would be very inconvenient that every time you navigate to my next page in my private section, right, that I would be challenged again. Are you still? Is it still you? Is it still you? Is it still you? Instead, we're going to store some of that information on the server. Very small, right? Very tiny. Makes it a little less stateless. Okay. But it's the footprint is very small, right? The only thing that we really care is the user ID. That's the only thing that we're going to remember. Maybe a couple other things, but it's going to be really tiny. All right, so to do this, to be able to support stateful servers, we're going to need these two libraries. Okay, one of the libraries is called Cookie Parser. And cookies is the main mechanism that we're going to be using to maintain state. Right? The way cookie works is that when the cookies were invented, when we realized when HTTP just came out and the website and the World Wide Web just came out, and people started just exponentially creating lots and lots of ways of how to use it and invent, right? They realized that there was no way for they realized that the protocol, the HTTP protocol, was designed initially as a stateless protocol. Well, it's still a stateless protocol, right? It's a protocol that cannot distinguish one request from another request, right? If you come from one location and you come from another location, it's the same for anybody. If it's come from the same location, it's the same. It doesn't know who's who. There's no way to distinguish. So this limited a lot the types of application that we could build. Right? So for instance, if I wanted to remember that it's my shopping cart. There was no way for the server to distinguish that this is your shopping cart versus somebody else's shopping cart. There was no way for it to remember that you came yesterday and you asked for the weather for a particular zip code, and you probably want the weather for the same zip code that you asked yesterday. Yes? So there was no way for it to remember anything. So the mechanism was invented or devised so that headers, HTTP headers, were added to the protocol. That servers would ask the client, "Hey, client, here's a little bit of random piece of text, okay? And can you please store it in your local environment, right? In the browser, store it in the browser's machine, okay? Next time you generate another request, okay, provide that same piece of text that I gave you, all right, and send it back to me, because I'm going to make a note. I'm going to make a note, right, and that I gave you that ID. Next time you come around, if it's the same ID, I'll remember that it's you. Right? I'll make a note in memory, right, that I gave you that string. If you give it back to me, I can have a small RAM location where I can store information there that I can map to that ID that you give me. Okay, and so this mechanism was called the cookie, using cookies. Okay, certainly we've misused cookies in all sorts of ways, and folks are somewhat reluctant at first, very very early on, at using cookies. This is, oh my goodness, they're keeping track of what I'm doing, and what are you storing in this cookie? There's some security concerns. Today we've come to accept it, and there's no meaningful website out there that can't do without cookies. Okay, and so today is still the main mechanism that we use to maintain state. Okay, now on top of that, so cookie is the main mechanism, the very low-level mechanism that is used to maintain state. On top of that, we're going to use this other library called a session, which builds an abstraction on top of the cookie, of this cookie mechanism. Right? It uses a cookie, right, and it maintains a hash map, right, based on that cookie. Right? So that if a request comes from one user, which provides cookie 1, 2, 3, there will be a hash map for that cookie 1, 2, 3. If some other user provides another cookie 2, 3, 4, right, there will be a hash map only for that one user. Yes, and what your code does, your library, when you use a session library, you don't have to deal with what the actual value of the cookie is, right? All that is going to be abstracted for us. By the time the cookie comes in, it gets parsed by the session. What we get is just a hash map, right? And we treat the hash map as if we were treating it as if it were the single hash map, right? So we can generalize the mechanism of interacting with this state information for that particular user. So cookie parser is what allows Express to be able to parse the cookie, just like we have body parser. Yes, well, there's cookie parser. Right, out of the box, Express doesn't know how to parse cookies, how to extract from the header, how to retrieve the cookies, how to set the cookies. It doesn't know how to do that. Right, so a cookie parser allows you to do that. And on top of that, this is a thin layer of abstraction on top of the cookie, so you don't have to deal with the low-level headers. Okay. All right. So internally, we need to install that. So let's do that. Let's see. Let me close this. It's still recording, right? Yes. And let me close this. And I think it's this one, the one we're working on. Okay, let me make sure that it's not already. Maybe it's already configured in server. You see? Okay, let's see. I don't believe it's already configured. Okay, so it's not. It's not already configured. So let's npm install cookie parser. So let's do that in the terminal. Are we in the right place? Yes. Okay, so this is going to install cookie parser, and don't forget the -- save. Right, that's going to include your library as a dependency in package.json, so that when you deploy it to Heroku or wherever you're hosting this, it will install that library. And then also install the Express session library. Both of these libraries used to be part of the Express library, but Express has grown so much, right, and does so many things that that now they've been broken up into their own little modules. Right, so you need to install them separately. Okay, so they're installed in package.json. We have cookie parser now, and we have Express session. Very good. So once we have that in our server.js, we'll need to load them as dependencies. Let's do that. And these could be const. So const cookie parser, we're loading both of those libraries. And we also need to initialize them. Okay. So first we'll set up cookie parser, and we'll say what this does is it sets up a middleware. We're telling Express that for every request, right, that comes in from the client, make sure to look and parse for those headers. Right, parse them. Okay. So intercept all that communication, and then the session. Okay. Now the session takes as argument a secret, right? This secret is just a plain string. It's a plain string that it uses to encrypt the cookie, right? To make sure that the cookie, as it goes back and forth, right, it's encrypted so that even if somebody intercepts the communication of this cookie, folks cannot take your identity. Okay. Now, typically, this would be configured in your local environment, right, as an environment variable, right, either in the operating system, or if you're in Heroku, it would be configured in your as part of your environment variables when you configure Heroku. Yes, and it would read it. You would read that from here, okay? Because it's a bad practice to provide a string right here. If you provide that string, when you post it into your when you push it to GitHub, right, it would be clearly visible what your secret is, right, and it could be used against you. I'm going to actually leave it like this since I'm not going to configure the environment. But you don't do that, right? Make sure that you have it configured and in your environment. Yes.
So let's assume that I can catch up one cookie from my friend's computer somewhere, and
Yep.
replicate the same cookie in my request. Will it maintain this session or?
Say again.
As in, like, I get hold of someone's Google account. I was using my friend's PC. I was able to send it.
And with the same secret?
Yeah.
If it's the same secret, yes.
The same ID.
Yeah, with the same secret, yes. Yep. Because it uses that to hash and unhash.
Saying that it's in the server, I don't think it's encrypted yet.
Yeah.
That's right. It's in a PC, so even if I sniff it, the encrypted form
Yes, you would.
ID.
Yes, you would. Now, but if you're using Google though, or Facebook, they not only is that encrypted, they also give you a token, right? So that the secret would be okay for for 30 minutes, so that even if you sniff it, within 30 minutes it would time out, right? And so that it would also provide you a token, an additional token, right? That would time out after whatever, right? So you have to provide that as well.
So how does that happen automatically? Like, I don't have to sign in my Facebook for years.
Oh no, you would have to use it yourself.
Okay.
Right, to verify that token is still valid or not.
Oh.
Okay, so if you grab that token, which you would typically do, right? You would grab you would grab the cookie and you would provide also have that token, but you can't generate that token, right? So that token would be good for you for the next whatever 30 minutes or not, right? After that, it would time out, and then you would no longer have it, and that token would have to be changed, regenerated, and you have to sniff it again.
My question is that I have logged into Google,
Yeah.
and let's say that the token is not updated for 2 or 3 days. As you said, it's updated
Yeah.
in 30 minutes.
Yeah.
Now, let's say I'm the same user and I'm trying to log in again, but then it doesn't ask me to enter my username and password. It simply updates the token. Is that what you're trying to say?
Yeah, it
It
doesn't.
simply automatically update the token irrespective of me logging in or using Google service at all.
Yeah, the token is updated. The token is updated. You can configure how long the token is good for, right? And as long as that token is good, you can still use that identity. Google never logs you out, right? It assumes that you're going to be using the same authentication forever, right? It is your responsibility on your server, right, to invalidate that token, right, and say no, that token is not good anymore.
And they also have this mechanism where if you change your username and password, it will automatically log you out from all the different sessions
Right,
you had
right.
on different devices.
Yes.
So
Yep.
is it the same like cookie management, or is something different happening on the server side?
Yeah, no. Every time it go through Passport, Passport goes back and provides the same information to Google, right? And Google comes back and saying whether it's valid or not. Right? So it's not it could be cached and you could have stale information on your server, but Google is always up to date, right? So if you change your password elsewhere, right, you would be also logged out from anywhere else where you have a Google identity. Right. So all applications to have to use Google authentication need to register with Google, right? And so it would know that, oh, this application hasn't yet been unauthorized, right? So they will all be going to the same authentication provider, right? And if somebody has changed their password or whatnot, they would get back an invalid that they have to, well, not an invalid, they would have to re-authenticate with Google, and then they would get a brand new token, brand new identity, and everything. Yep. Yep. Yeah. Okay. Great. Okay. So we have those two. The cookie parser, and the session is going. Although I am going to provide here a bogus string. It doesn't matter what string it is, as long as you know what the string is. It could be just some random piece of text, right, that it uses to encrypt. All right. So we have that. The next step is that we need to install the necessary Passport libraries. Okay? First, we'll install the core Passport library, which is just Passport, right? And then we'll also install the various strategies that we're going to be using. Right? We're going to be looking at three strategies. One is the local strategy, which is meaning we are going to be the authentication provider. Right? Our database is going to be our authentication provider. But then next week we're going to take a look at using Google or Facebook as the authentication provider. We'll need to install that strategy separately. So first, let's install Passport, the core Passport library. Okay, there it is. And then we'll need also the local strategy. Come on. There we go. Installing the local library, and let's make sure that package.json is updated correctly. Maybe? No? Do we see Passport somewhere? Oh, there's Passport. All right, still, and Passport local. Do we see Passport local? I don't see Passport local. Close all. Passport. Passport. Huh. Where'd Passport local go? Hmm. passport local. All right, I'll take a look at that. Meanwhile, let's configure now passport. Once we have passport, we need to configure it. Right? We need to tell it, hey, passport, I have set up a cookie. I have set up a session for you. Start using those. Right? So we're going to load a passport from our server. I just load it here, just alongside with all the other libraries. Okay. And then we're going to initialize it. Initialize it. Now we need to initialize it after we set up the cookie parser and after we set up the session, because we wanted to use the session we just set up. Right, so it needs to be after. It cannot be before. It needs to be after you set up the cookies and the session. Right? In that order. Okay. Oops. There we go. Okay, we set up the cookie parser and the session. We initialized passport and we told it to use session. Okay? All right, so now we have passport configured. So next, we have in our local environment, we have two servers running, right? We have one that is hosting our AngularJS development environment, right? That is running at port 4200, and we have the server running at 3100, correct? So we need to, because we're going to be using security, we used to have our course be configured so that requests could come on from anywhere. Right? We had here in our access control allow origins. This used to be an asterisk, meaning from anywhere. Right? But when you use the security, asterisk is not a valid option. Okay? We need to specifically say if it's coming from a different domain. We need to specifically give the permission to come from that particular domain. Right? So we're going to change it to at least in development, we're going to tell it that it's not from asterisk. Okay, we're going to change it from asterisk to HTTP localhost 4200. We're saying, hey, this domain, specifically, I've given this domain permission to come and authenticate with me. Right? We're going to be exchanging cookies. We're going to maintain session. We're going to be encrypting back and forwards, right? And so I'm giving this particular domain the permission to exchange security information with me. Right? When you do this on Heroku, you won't have this issue, right? Because it's going to be the same domain, right? The Angular is going to come from the same domain as where it's receiving that security information, right? So asterisk is just fine, right, when you deploy it on Heroku. Okay. Here it's not fine because the browser considers these to be two completely different domains. One running on 4200 and one running from 3100. So here we specifically need to give it permission. The other thing that we need to add, so this is another header saying that there's going to be credentials exchanged here that are going to be encrypted backwards and forwards, right? The cookie that's going to come from the server is going to be encrypted, right? And the cookie that is going to be sent back is also going to be encrypted. Yes. So we have to turn that on. We have to tell the server that we want to support security credentials. Right. We're going to turn that on to true. All right. Okay. All right. So we have that. The other thing that we're going to be keeping track of is that as the user is being authenticated and as we're sharing, as the server shares user information with us, right? We would like to be able to maintain the currently logged in user. We're going to keep track of it on the client side, right? We're going to maintain that state so that we're no longer going to encode as part of the URL. We're not encoding the ID of the user, right? Instead, we're maintaining the identity of the user in a local shared service. Okay, so let's declare that. Let's create a brand new service on the client side. a shared service. So this is a shared service client, new TS. So this is shared service client.ts. And in there, we are going to declare our brand new shared service. We declare this, and we want to then declare it as a provider in the module. So this shared service is kind of a place for us to put things that we want to be available all throughout the component. So every component, wherever they put here, will be available for all the components. Okay. In this case, we're going to be keeping track of the currently logged in user. Right? So that once we get a confirmation from the server, we can store it in there. Okay. In the module, we're going to add the new shared service as a new provider. All right. All right. I think we have the minimum that we need to get started, right, and start using Passport. The next step will be to actually start using it to refactor what we already have in place. Right. We need to refactor the way we register. We need to refactor the way we log in. We need to refactor the way we view our profile. We want to remove the ID from the URL. Right, and so we have to maintain some of that information now on the server side. Right, so let's start refactoring what we already have. We'll do that next.